Hello students, as you are observing on the board, it is written over there sound. So today we are going to discuss about the topic sound. As we know that sound always produced by a vibrating body, means if a body is vibrating or if a body do some vibration, they always produce sound. If we are unable to hear or hear any voice, it doesn't mean that vibrating body does not produce sound. It produces sound, but if you people are unable or we people are unable to listen those sounds. But if anything is vibrating, they must produce sound. They may be of loud, maybe of very smaller one, that doesn't matter. But if any body vibrate, it must produce the sound. Then our next topic is form of wave. If sound is from vibrating body, it always in longitude produce longitudinal wave. Wave. What is the meaning of this type of wave? If suppose this is a particle, this is a object and it is vibrating, either vertical one or horizontal one. So this type of vibration always produce sound. But sound wave, sound though it's a vibrating, it travels a medium and reach up to the air, it must be in form of wave. Which type of wave? It is a longitudinal wave. Longitudinal waves are those waves in which particles are vibrating in the direction of the propagation. My word is very clear. Particles are vibrating in the direction of propagation of wave. Such type of wave is known as your longitudinal wave. For example, let me see where you are. Yes. For example, see this side. Suppose there is a object A and start to vibrate in this mean direction up to this one, and this is moving and this hit other object B and B start to vibrate like C. Clear? So this medium and here sound also travel in this direction. So this type of wave is known as your longitudinal wave. One more example, let me explain. Sound wave is an example of longitudinal wave. And what is the meaning of longitudinal wave? Suppose there is a particle, clear, and it start vibrate in both the direction likewise. Means what? It start to produce sound in this direction. So while vibrating, this vibrating body hit the particles present in the air, particles of air in front of it. I am speaking, so my vocal cords are vibrating and they produce sound. This sound reaches up to you. So by using in my class by using the wave, and that wave is longitudinal wave because my particles just in front of my mouth here receive the vibration and start to vibrating in this direction, not in upward downward, in this direction. This is known as your longitudinal wave because I am speaking in this direction, and particles along with this direction of the sound, they vibrate in this direction likewise. Clear? So this is your longitudinal wave, and if particles vibrate perpendicular to the direction, that is not the longitudinal, it is your transverse wave. That is your transverse wave that we discuss afterwards. So hope this type of wave is clear to you. Now always remember that sound is an example of longitudinal wave, and sound always produced by a vibrating body. It doesn't matter if it's a vibration of vocal cord, vibration of your steel scale fixed at one end and you start to push and throw it, that is a vibration of your bees. They vibrate their wings so that you can listen the sound, that cell sound. Even vibration of mosquito's wing, you can easily listen that sound if mosquito comes nearby you, near your ears, so that you can easily listen those sounds. So sound always produced by a vibrating body. Now in physics lab we are generally used some tuning fork. What is tuning fork? It is an equipment having fork-like structure, but in this case likewise this is your tuning fork. This type of steel made heavy equipment is known as your tuning fork. This tuning fork always produce sound, and it have two parts. This one and this one, known as your prongs. Clear? Prongs. And this is your stem. We hold the tuning fork by using stem and hit on a rubber pad hit prongs on rubber pad so that these two start to vibrate. But that vibration is not visible to us, but if we bring those vibration nearby us, they produce sound. We can easily see the sound. You can check this whenever you come to school. You can check it in physics lab. So how we know that this prong vibrated? If we take that vibrating tuning fork and try to place nearby some light particles, that light particles with the effect of vibration, they move away from the tuning fork. It shows that tuning fork is vibrating. For hearing a sound, some conditions are necessary. For hearing a sound, some conditions are necessary. Those conditions are: first, there must be a vibrating body. That already discussed. Second, there should be a natural medium or medium. Medium may be solid, may be liquid, may be gas state, but we need some medium. In vacuum, we are unable to listen the sound because in vacuum, in space, there is no medium, so we are unable to listen the sound wave, receive the sound wave. And at last, third point is there should be a receiver. There should be a receiver who receive your sound wave. So already discussed the vibrating body. Now we are going to discuss about natural medium. Medium may be solid, may be liquid, may be gas. Whenever you place your ear on your desk, your desk of your classroom, and hit one part of the desk by yourself or by with the help of your friend, you can listen the voice on the other end of the desk where your ear is placed. So from this you can easily say that sound can travel in solid type of medium. In liquid also you can easily receive the sound because liquid is a medium. For this we can say that whenever you place some empty bucket or filled bucket inside the water and try to hammer that bucket, you can easily receive the sound just above the or inside the water easily. So you can easily receive the voice in liquid also. And in gaseous medium like air, we can easily listen the voice, listen the sound. But always remember that sound travel faster in solid and slower in gaseous medium, moderate in liquid part. Always remember that sound needs a medium. For this we can use some bell jar experiment. So I'm going to discuss about bell jar experiment for you. We take a pretest likewise, clear, and there is some airtight container in which we can insert two wires, and these wires are attached some electric bell, clear. This is your bell, and just below it there is a arrangement so that we can easily remove the air present inside this container. My drawing is not too good, but you can easily understand. And this wire is attached with some battery, clear. So when we switch on this device, this current, we can easily receive that we can see the bell is ringing, that hammer is hitting the gong, and we can easily receive the voice. So first we try to ring the bell and that hammer is hammering the gong, that sound we can easily receive by using our ears. Now next step, by using this arrangement we can remove the air inside the container, inside the apparatus, and be fixed that every part is properly sealed so that no air can enter inside the container, inside this container. And then we switch on the bell. We can easily see that hammer is hanging the gong of the bell, but we are unable to receive the sound. So this proves that sounds need medium for traveling. You can read this part of your experiment in your book. As we discussed just few minutes ago, that sound needs medium to travel. It means sound must has its own speed. Depending upon the medium, sound has variable speed in different medium. In air, generally in air, we have a known speed. Its speed is in air 332 meter per second, depending upon the temperature also. In water, that is a liquid part, in water, speed of sound approx 1500 meter per second, and in steel, that is your solid part, it's approx 5100 meter per second, and this speed is variable depending upon the temperature also. If we increase the temperature, we decrease the velocity decreases, and if we decrease the temperature, velocity increases. All these speeds taken at normal temperature, that is your 25 degrees Celsius. So hope this one is clear to you. You must learn all other velocities in different medium for a sound. How we find the speed of a sound in a given medium? Suppose how we find the sound in air. It's very easy experiment. We know that light travel faster than sound, so for that two persons A and B separate at a known distance, say it's 1 kilometer, it's a 1 kilometer, clear, and they stand in such a condition that they can see each other very easily, whether by using your naked eyes, by using some binoculars, but they can see each other easily. Now, with A having some flare gun or some gun which produce sound as well as light. We know that in shotguns and guns always produce sound or light also. Do this experiment during night so that you can easily see the light and listen the voice. And this B is with binoculars so that they can easily see what is happening over what is A's activities. B can easily see. So whenever A fire, B easily see the light. B start the stopwatch. Note the time, start the stopwatch, and as soon as B listen the sound of the firing, that is gun, B stop the stopwatch and find out the time interval. Find out the time interval. Time interval means what? That time between the light, seeing the light and receiving the sound. And then use the formula of speed as equals to d upon t, We know the d, it's a 1 kilometer. We know and from observation we can find out the t, so we can easily find out the distance, speed of a sound in a given medium. Okay, then one more question says that, sir, why light travel faster than sound? Because light needs no medium. Light can travel with or without medium properly if there is no obstacles in the medium in the path of the light ray. The speed of light rays is 3 into 10 to the power 8 meter per second. This is the speed of light. But as we know that speed of sound is 302 meter per second. So in these two speed there is too much difference. This is about your light, this is about your sound in air. So we can see the light within a second, within a movement, and we can it takes some time to listen some voice. All of you must read your book and try to complete your unit 1. In next video we'll discuss unit 2. That's all for today. Thank you.